Welcome to the sixth part of trigonometry chapter. So in this sixth part of trigonometry chapter, we are going to learn about the elimination. What is elimination? Everything I'll be explaining in detail. Before that, let's recheck your answers with my answers for the previous practice questions. So the first question was, if sine square theta equals to 1 by 2, then analyze and assess the value of cos square theta. So they're asking you cos square theta, and they gave sine square theta value. Sine square theta value is equals to 1 by 2. So this question is from the trigonometric identities. So there is any formula? No, not any formula. It is a formula derived from an identity. Can you guess which identity is that? Yeah, cos square theta, sin square theta plus cos square theta equals to 1. So cos square theta equals to 1 minus sin square theta. So cos square theta equals to what? Sin square theta value is 1 upon 2. So I'm equaling the denominators. It becomes 2 minus 1 by 2. When I like 1 minus sin square theta means 1 minus 1 by 2. So near 1 there is no denominator. So I'm just taking, if anything is not there, then we can imagine as by 1. So, and I have equaled the denominators, and 2 minus 1 equals to 1 upon 2. This is cos square theta value. So this is how you find out the answer for the first question. And coming to the second question, analyze and assess the value of cos 4a minus sin 4a. So instead of theta, here they give a. So what's the relation between cos and sine? Cos square sin square theta plus cos square theta equals to 1. So cos 4a minus sine 4a. So can I write this cos as cos square a whole square, so that it's the same? Am I right? See, square and square, you'll get 4. So in the same way, I am writing it for sine also, whole square. So after doing whole square, isn't it if I make it a whole, that means cos square a minus sine square a into whole square. Is this the same for both of them? Yeah. So isn't it looking like a minus b whole square? So what's the formula for a minus b whole square? So a plus b into a minus b. So I'm doing the same now. Cos square a plus sin square a into cos square a minus sin square a. So this is how you do. So cos square, instead of theta, a is there. Am I right here? So cos square theta, instead of theta, there is a. So let's say cos square a plus sin square a is equals to 1. Am I right? Cos square a plus sin square a is obviously 1. So 1 into, because cos square a plus sin square a is equals to 1, and cos square a minus sin square a remains same. So cos square a minus sin square a will be the answer. So if 1 into something is also something, so cos square a into minus sin square a. This is the answer for your second question. This is how you solve your practice questions. I hope that those were easy questions. So now getting into the actual topic of part 6 of trigonometry, elimination. What's meaning of elimination? Elimination is nothing but between any two equations, one unknown quantity will be involved. So we can eliminate that unknown quantity by using a proper identity or some fixed value, like making a equation without those particular symbol or that quantity basically. So there's nothing more about looking at this, but then I'll give you examples so that it will be even more easier. So what's elimination? Elimination is eliminating an unknown quantity. So this is called as elimination. And coming to an example, so let's eliminate theta from x equals to a sine theta and y equals to a cos theta. So from this, let's eliminate theta. To eliminate theta in these two equations, what you have to do is squaring on both sides. That means x square is equals to a square sine square theta and y square a square cos square theta. That means I'm adding a to the both of the equations to eliminate the theta. So now, like, can I write this x square as yeah, can I do equation 1? Equation 1, like, let's take this as equation 1 and let's take this as equation 2. I wanna add these two equations. Then what will it happen? X square plus y square equals to a square sine square theta plus a square cos square theta. This is what it happens. And next is what will happen. So here, so here, can I say that a is common? Here a is common, for here also a is common. So anything based for sine and cos, some relation is there for these. Yeah, sine square theta plus cos square theta. Even it is in addition itself. So the extra is a square and a square. So in the next problem, I'm just taking it as common. Let me take it as common. Okay, so it becomes a square equal to sine square theta plus cos square theta. So it becomes a square equals to, a square into 1. Sine square theta plus cos square theta equals to 1. So here I'm not involving this theta. Instead, can I say that x square plus y square equals to a square? That means what's the equation for x square? A square sine square theta. I eliminated theta, so I can write it as x square. Even same for the y. Also, I squared on both sides and I am adding the two equations. So I am getting the answer as a square. So equation of any, like, addition of any two equations for this given particular quantity, it is 1. So obviously a square. So the answer will be x square plus y square equals to a square. This is how you have to do it. Coming to the next example. So given that x secant theta minus secant theta plus tan theta, so secant, okay, let's take this as x. X equals to secant secant theta plus tan theta, and y equals to secant theta minus tan theta. So there is some relation that secant is same, tan and tan is same, but the fundamental operations are wrong. So can we write it as, so is it like looking like x into y equals to secant theta plus tan theta into secant theta? Is it looking like secant theta plus tan theta into secant theta minus tan theta? So a plus b into a minus b is equals to a square minus b square. That means secant square theta minus tan square theta. So secant square theta minus tan square theta equals to 1. That means x into y is equals to 1. So multiplication of two equations gives 1 for this particular value. So this is the second example, and let's have a third example also. So example 3, eliminate theta from the following equations. So sine cube theta equals to b and cos cube theta equals to c. Now what can we do? So there is like this is a kind of a different thing. So what I wanted to do is sine cube theta equals to b. So I want to equate it like sine theta. So I just want to transfer everything, this cube, to this side. So it becomes b 1 by 3. 1 by 3, it is because this 3 is of sine's power, but b's power will be 1 and sine's power will be 3. So I just want to make the LHS simple. That's why I'm sending it to RHS, but the RHS actual power will be 1. So what I want to do is, so I want to just make this as sine square theta. So when I make this sine square theta, I'm taking back 2, so it becomes b equal to 2 by 3. And what about cos cube? Cos cube also same, equals to c. That means cos theta equals to c1 by 3. I'm sending this power that side. So I just want to make it cos square theta. So cos square theta equals to c2 upon 3. So now I'll add. So let's take this equation as 1 and this equation as 2. So now I want to add equation 1 plus equation 2. So equation 1 is sine square theta. Okay, let's do it like, okay, sine square theta equals to b2 upon 3 plus, it's the same I guess, right, plus cos square theta equal to c2 upon 3. So what does it become? Sine square theta plus cos square theta equals to 1 equals to b 2 upon 3 plus c 2 upon 3. These two values remain same. Here they asked you to eliminate the theta, so we eliminated theta. So basically in this elimination point, the only thing you have to see is whenever they give you some trigonometric ratios, you have to first check there is any relation between those two trigonometric ratios, and you have to equate it to that, or not equate it, but then you have to make that equation like by by doing subtraction or addition somehow. See, the question what they asked is sine cube theta is equals to b and cos cube theta is equals to c. See, sine and cos, there is a relation, there is an identity, but to make that identity, that means to form that identity and get the value as 1, you have to do all this derivation. The thing is, you have to keep this thing in your mind. So this is how you do it for the elimination of theta, or not just theta, but then in some cases instead of theta they may give, like for example in this question itself, they ask in place of theta, if they ask cos cube a, then you have to be like, you have to keep, instead of theta they ask you to eliminate a by giving instead of theta a. Like for example, let's take, instead of this cube, if they ask you cos cube a, eliminate this a. So you do the same process, instead of theta you keep it as a. That means you are eliminating a in that particular process. So this is an example 3. To make even more easier, I'll explain you one another problem. So the another question is, like let's take a equals to x cos theta plus y sin theta and b equals to x sin theta minus y cos theta, and they are asking you to make some relation with x and y and eliminate this theta. So now there is some relation for cos and sine. So to do that, first we have to do squaring on both sides. Like see, cos square theta plus sine square theta equals to 1, or sine square theta plus cos square theta equals to 1. So it has to be in square. So I wanted to do squaring on both sides. So if I do squaring on both sides, I will get, so a square equals to x square cos square theta plus y square sin square theta. And so for this, let's complete it. So instead of writing in this big much form like x square cos square theta plus y square sin square theta, we have another thing now. So can we write it as whole x cos theta plus y sin theta whole square. So is it looking like a plus b whole square? So what's a plus b whole square formula? A square plus b square plus 2ab. So let's take this as a, this as b. So a square means x square cos square theta plus y square sin square theta plus 2 into x cos theta plus, not plus, right, here multiplication, into y sin theta. Here you have not used squares. So this is about a square. Coming to b square. So what's b square? So I'm using the same, b square equals to x sin theta minus cos theta whole square. Sorry, y cos theta. So again a plus b whole square formula. So b square equals to x square sin square theta plus minus y square cos square theta plus 2 into x sin theta into y cos theta. So here they said x sin theta minus y cos theta. Minus is there, so this becomes minus instead of plus. So now I wanted to add, so okay, let's take this equation 2 in the previous one, this one, no, not this one, this equation as 1. So now I wanted to add equation 1 plus equation 2. So what's equation 1? A square equals to, okay, we don't have lots of space. Okay, now a square equals to x square cos square theta plus y square sin square theta plus 2 into x cos theta plus into y sin theta. And what's b square? B square equals to x square cos square theta plus y square sin square theta minus 2 into x cos theta into y sin theta. Right? Am I clear? Sorry, it's reverse. I'm so sorry. Sin theta and cos theta. Now as I wanted to add those equations, so plus 2ab minus 2ab get cancels, so x square into cos square theta, here cos and sin get cos square theta minus sin square theta equals to 1 plus y square equals to sin square theta minus cos square theta equals to 1. So 1 into 1 equals to 1. So x square plus y square equals to, that means can I write it as a square plus b square? Am I right? Those x cos theta plus y sin theta and b equals to x sin theta minus y cos theta. So I'm taking it as a square and b square, as we did squaring on both sides, equals to x square plus y square. So x square plus y square is also equal to a square plus b square. A square plus b square is also equals to x square plus y square. So this is how you have to eliminate theta from the following and also do all such things. So I hope you're clear with this. So I'll be giving you 2 practice questions. I hope those will be easy for you, and if any doubts, please let me know. And yeah, thank you. So these are your 2 practice questions. So eliminate theta from the following equations. I hope these are easy. The answers for these 2 questions will be uploaded in the next video. Thank you.